guys, this is Mrs. Harbin, and this is Advanced Math. Today we are looking at section 10.3, which is a continuation of factoring. So in the previous lesson, we looked at how to factor quadratic expressions where the leading coefficient was 1. So all of our expressions just started with x squared, or 1x squared. Today we're going to look at what we need to do when our leading coefficient is not 1. But first, let's do a quick lesson opener, get your brains warmed up here, and find the missing term or coefficient in each problem. So let's take a look here. We know that when we multiply this, we want to get 2x squared, and 2 times something minus 3 something is going to give us positive 5. Well, I know that 8 minus 3 is positive 5. All right, let's see if that works there. What if we tried an 8? 2 times 8, nope, 2 times 4 would have to give us the 8. And then we know our last term needs to be negative 12, and negative 3 times positive 4 is indeed negative 12. So the 4 does work there. All right, what about your second term? X plus 5 times something plus 2. Well, I know my first terms multiplied have to equal 3x squared. And x times what equals 3x squared? Hopefully you said x times 3x equals 3x squared. Okay, what about our last one? We know that this is our last term here. And when we multiply our last terms, we want to get to a negative 20. Well, what times positive 4 equals negative 20? Hopefully you said negative 5. All right, what about the missing terms here? Again, we know that our first terms multiplied are going to give us 7x squared. So we can see that we're missing a 7x. And our middle term is made up of our outside and inside terms. So if we were to multiply those and then combine like terms, we would get 18x, because 4 times 5 is 20x, minus 1 times 2. So 20 minus 2 is 18x. All right, so again, today we're looking at factoring this form, ax squared plus bx plus c. Before, our a was always a 1. Now we're going to introduce some other numbers. Now the method that I'm going to teach you today, you can use anytime you have a quadratic, even when your leading coefficient is 1. So you can use this every single time. You don't have to use the little shortcut that we introduced in the previous lesson. Let's take a look at 3x minus 2 times x plus 5. So we have two binomials being multiplied by each other. When we multiply those out, we get 3x squared plus 15x minus 2x minus 10. Combining like terms gives us 3x squared plus 13x minus 10. You should notice that the 3x squared is the first terms multiplied. 3x times x, 3x squared. And my negative 10 is the last two numbers multiplied. Negative 2 times 5 is negative 10. And my middle term is the sum of the middle terms, of the outside and the inside terms. If I multiply those and then add them together, like I did here, I get my middle term. Knowing that is going to help us with our factoring. So when factoring, we want to factor 3x squared plus 7x plus 2. We know that our a and our c equals 6, and our middle term, b, equals 7. So we want to find factors of a times c that equal 7. Now, I did give you a handout in class that show you 3 different ways that you can kind of organize this information. Some of you might like to make a chart of the factors of 6, 3 times 2. Positive 6, we have positive 1. Sorry about that, and that's a 1, a positive 6. We have a positive 2 and a positive 3. Or we know we could have negative 1, negative 6, negative 2, negative 3. We then know that whatever we choose has to sum to our middle term. And I know that positive 1 and positive 6 equal a positive 7. So I'm going to rewrite my middle term with these two factors. A positive 7 is the same thing as a positive 1 and a positive 6. From here, I can do something called factor by grouping. I can look at the first two terms, group those together, and factor a common term, and look at our last two terms and factor out the greatest common factor from each group. So I have 3x squared plus 1 and 6x plus 2. 3x squared and 1x, they have a common greatest common factor of x, so I'm going to factor that out. That leaves me 3x plus 1. I should always have a binomial left here. Don't drop that 1. You still need it. And then 6x plus 2, the greatest common factor is 2, which leaves me with a 3x and a 1. If you've done this correctly, you'll notice that what you have in parentheses is identical. That should be the case every single time. So 3x plus 1 is one of our factors. And then what we factored out, the x plus 2, becomes 10. To check to make sure we've done this correctly, we can always FOIL, multiply that back out, and when you do, you get 3x squared plus 7x plus 2. When you're factoring trinomials of this form, ax squared plus bx plus c, and actually any quadratic expression or quadratic equation will work with this, even if your a is 1. But when factoring this trinomial in this form, you want to find factors of a times c, so a times c, whose sum is b. We then will rewrite the middle term as the sum of those two factors, the factors of a and c that we found, and we'll factor the 4-term polynomial by grouping the terms in pairs. We'll factor the common monomial from each pair and factor the common binomial from each new term. We'll then check our factorization by multiplying the factors and making sure that we end back up at our original expression. Let's try factoring 2x squared minus 19x plus 24. Now, you saw me before make a little chart of our a times c. 2 times 24 is 48, and try to find two factors that equal negative 19. Some people prefer to organize their information like this. 2 times 24 is 48. And then they think of sums of, or factors of 48 that sum up to negative 19. Well, I've got a negative 12 and a negative 4. That doesn't equal 48. I know that it's going to be negative because I've got a negative 19, but negative 16 and negative 3, when multiplied, that equals 48, and when added, it equals negative 19. My 2x squared comes down, and my 24 comes down. And my negative 19x becomes negative 16x and negative 3x. From here, I go ahead and factor by grouping just like before. So instead of making a chart like I did in the first problem, some people prefer to use this M method, if you will, because it kind of looks like the letter M, to organize their information. All right, let's go ahead and see what this looks like. We've got 2x squared minus 3x minus 16x plus 24, like we just said. And now we'll factor by grouping. 2x squared and negative 3x have a greatest common factor of x, and negative 16x plus 24 has the greatest common factor of negative 8. You see that I did do that correctly because I have the same thing in parentheses. So 2x minus 3 is one of my factors, and x minus 8 is my other binomial factor. If we were to multiply that back out, you would see that we would get back to our original expression. So we did factor that correctly. If you want to check that on your own, feel free to do that. For example 3, I'm going to show you a different technique or a different organization method, if you will. Some people prefer to use an x. And in the x, they write their a times c up here and their b down here. So our a times c, 3 times negative 7 is negative 21. And our b term, oh, I just realized I made a mistake here. If you notice, we don't have our expression in order. The very first thing we need to do is rewrite this in order from our x squared term, our quadratic term, linear term, and then our constant term down at the end. So I'm going to rewrite this as 3x squared minus 7x minus 20. And now that I have that rewritten, now I can take my a times c. 3 times negative 20 is actually negative 60. So let's write that here. And our b term is negative 7. So let's think of the factors here. Because we do have a negative 60, We know that one of our numbers will be positive and the other one will be negative. So what are some factors of negative 60 that when added equal negative 7? Our bigger factor is going to have to go over here. Well, right off the bat, I think of negative 12 and positive 5. Negative 12 times positive 5 is negative 60, and negative 12 plus 5 is negative 7. So let's go ahead and split our middle term and rewrite that negative 7x as negative 12x and positive 5x. There we go. Once we have done that, we can group and factor by grouping. Our greatest common factor for 3x squared is actually 3x, so we're going to write that, pull that out here. And our greatest common factor of 5x and negative 20 is 5. So let's see what that looks like once we factor that out. We end up with x minus 4 and x minus 4 in parentheses, so we did factor that correctly. And 3x plus 5 will then make up my other binomial. So we end up with 3x plus 5 times x minus 4. Again, feel free to FOIL that and multiply it back out to check your work. When factoring, remember that the first step in factoring a polynomial is to factor out any common monomial factors. Before you even begin multiplying a times c and seeing if it adds up to b, you can make your work a little bit easier if you factor out any common monomials first. In the next example, you'll see that there is a common factor of 2x that we can factor out. So when we look at 12x cubed minus 26x squared plus 10x, each of these have both a factor of 2 and x that we're going to factor out first. That leaves us with 6x squared minus 13x plus 5. Now we can find the factors of a times c, whose sum is b. So we're looking for factors of positive 30, whose sum is negative 13. Because it's a positive product, I know that both of my signs have to be the same. And because it's a negative sum, I know they both need to be negative. And the two factors that when multiplied equal 30, but when added equal negative 13 are negative 10 and negative 3. So we'll go ahead and rewrite our middle term as negative 10 and negative 3. Notice that we still have this 2x out here on the side. We leave that there. We're then going to factor by grouping. We have 6x squared minus 10x and negative 3x plus 5. The common monomial here, or the greatest common factor that can come out, is a 2x. And over here, it doesn't look like we have anything in common other than maybe just a 1. So we can factor out that 1. We get 2x times 3x plus 5, and a negative 1 is what we'll factor out, times 3x minus 5. If we had factored out a positive 1, our signs would have been backwards. And we do need these two parentheses to match, so we're factoring out a negative 1. When we simplify that and write it as our factors, what goes in parentheses? What comes in parentheses twice is one of our factors. What we factored out here, 2x minus 1, becomes our second binomial, and we can't forget about that 2x that we factored out at the beginning. So our final answer is 2x times 2x minus 1 times 3x minus 5. If you remember, we started off with an x cubed term, which means we should have 3 factors. That exponent tells us how many factors we should have, and if you look, we have 1, 2, 3 factors. All right, let's factor 2x squared plus 3xy minus 14y squared. First thing we're going to do is look for any common factors that can be factored out of all 3 terms, and it does not look like there are any. So we're going to proceed as before, but let's not forget the y. We know that a times c is negative 28, and our middle term is going to be a b. Because this is negative, one of our factors is negative and one is positive. And because our sum is positive, the bigger factor is going to be positive. We're going to split that then into 7x and negative 4xy. 7xy and negative 4xy. 7 times negative 4 is negative 28, and 7 plus negative 4 is positive 3. We'll then go ahead and put parentheses around our groups and factor by grouping. The common factor in 2x squared plus 7xy is just x. And the common factor in our second grouping is negative 2y. We then put the two things that we have in parentheses here, they should be the same. That becomes one of our factors. And x minus 2y becomes our other factor.